Okay, so here we are designing like a product from a scratch based on a constraint, and that's this type of some kind of the car toy, the woodworking car toy. And the idea is that we have a certain materials that we need to turn into a toy, but it is not fully defined except the specs that we need to use in this case the dowel pins, so which is the 1/4 diameter and the 1/8 inch long dowel pin, and that we have a piece of wood for a car which is or 3/4 of the inch thick, and which is in a size, so which is the 3/4 of the inch thick, and that it is a wood scrape, which was not actually even given the correct size, but we can assume that this cannot be a more than like a 4x4. And we have, we have essentially the rest of it we don't need for a SolidWorks, and we need to use the wheels. So wheels will be used from the 3/4 of the 3/16 inch thick, and and 3/4 of the inch diameter. So we have a lot of things that we can say. Let's say that we can build a car in a size of about 2x3 maybe, or maybe about actually more than a 2. Let's say that this is a 4-inch by 3-inch, that is the maximum space. So we can choose one of these models, or we can come up with our own model of the car. So let's say that we are going to do the woodworking of this sport car. So then what we are going to do first, we are going to snip that photo, which will give us our pattern to work on, and we'll try to snip this as good as possible, as close as possible. And I will save this as a car body profile. And I will use this in a content of the sketch image to create a sketch. Okay, so now let's start the SolidWorks. And we will start building this assembly first by building the major car part, which is the body of the part. So we start in an IPS, and we are going to sketch on a front plane. And I'm going to sketch my bounding box. And let's say that I want this car to be a maximum of 4-inch of the length and maximum 3-inch height. So everything that happened, let's say that those are our scraps of the woods, and that we can't build bigger. So we are going to convert like the waste into a product. So that's the assignment. I'm going to change this bounding box to be for construction, so that I can freely move it. Now I'm going to bring in, under the tools, sketch tools, image, sketch picture. I'm going to bring the image of the car body profile, and I'm going to position it and to stretch it until it is within proportionally until I have it within my bounding box. The entire part need to be within the bounding box. And this will be a good. I'm going to change transparency to be able to see what I'm editing here, a little bit like this. Now I can start by making, let's say, a piece from here to here, the straight line. And I can put some dimension to 3.75 will be a good dimension. And now, how about for the car body itself? I will need to use the spline. So because I'm just retracing it, there is no dimensions given. There is nothing really given to define this car body, so we need to be careful how we will freely retrace it. Not too many points, because what happens when we have too many points is then actually, you know what? I'm going to also remove this point, so maybe I should actually end it there. This spline I should add here. The next spline, I will start from there. Actually, the next one I can use the line, because this is obviously 2 lines here now. And then I'm going really to make fillet here. There is nothing that say that you cannot use in free sketching, that you cannot use the whatever appropriate sketching tools there. Okay, and now we will continue with our spline. And press escape. Okay, as you can see, this will be approximately the proper number of points, because the spline is not wavy. It's kind of have continuous flow. If we want to fix this spline to have a fixed sketch, we can choose the splines. We can choose actually everything. And we can add fixed relationship, which will work. Here it is. So in that case, we don't need any of the dimensions. So everything is fixed, because that's not really a good parametric relationship, but it can help us in a situation like this. Okay, let's exit. The sketch is overdefined. Let's see why it is still overdefined. Oh, because we do have some, those dimensions are not fine. Okay. We can actually delete also these dimensions for the bounding box. Now everything is fine. All right. So now what I'm going to do, I'm going to extrude this body, extrude base for the thickness. And if I look back, what does it say that is the thickness of the plate? Scrap wood 1/4 inch thick, 3/4 of the inch thick part. So we are going to extrude it for a 3/4 of the inch, and we will just type in 3/4, and here is our extrusion. So here is the body of our derby car. Now we need to create position the holes for the dowel pins that we will use the dowel pins for the car's axles, for the car axles, for the wheels. The dowel pins we know that we need to use, which are 1/4 inch dowel pin, and the size of the dowel pin that they want us to use, it's the 1 and what is this, 1 and the 1/4 long, I believe. So let's increase the zoom here. No, 1.5 inch long. Yeah, so is this the 1.5? No, actually that's the 1.25. 1.25 inch long. Okay. So if I use the 1.25 inch long pin, then I will need to make a 0.25, the 1/4 inch. I will need to make those 2 holes. So if I go back to my body, I will make my sketch again visible, because the sketch kind of indicates where the holes will be. I'm now going to start a new sketch at the top here. And I'm going to position either a center line or 2 holes. I will put the center line because I will have the 2 holes at the end of the center line being here. And let's say what we do just for the, okay, 2.125. That's good. And we need to position it vertically. And that's exactly what we kind of wanted from article. They say 1/4 inch. And now we can place additional 2 points at the end. And I will use this sketch to place the holes. Now I will go back to the hole wizard. And this will be a through hole. And it will be for the dowel pin, dowel holes. And that will be a 1/4 the inch through hole. We can have some little countersinks. So let's see what is the tolerances here. We need to assure that our thing will move actually, that the axle, actually that the wheels will move. So I will just use the standard tolerances I will just use the standard tolerance set that the dowel pin hold offer to us. Because we will need actually to fix the shaft, and then we will need to make the wheels to turn around the shaft. Okay, so here is the dowel pin hole. Press OK. And we can actually make at the both end also to have that little chamfer. Back placing also at the far side countersunk. Call out diameters, okay, and the rest is fine. So, okay, and now we can close our sketch. Let's actually hide it. And here I'm now done with that car body. What else I can do? I can say that I want to sand it, so to have some smooth fillet, so that I don't have a sharp edge. So I can sand it. Let's say that we want a fillet of the 1/8 or 1/16 of the inch, which is reasonable to achieve with nice sanding. And we will need to choose all of the edges. Alright, and here I will save this one as a derby car body. Car body. Now I'm going to make the wheel. And to make a wheel, I'm going to start a new part again. And the wheel, I'm going to make this time by the revolution, so I can sketch on the front plane maybe. I will place the center line as a horizontal line. And I'm going to make the wheel in a one step and further on just add by making only a one rectangle, aligning the left edge vertically with the origin, specifying that the diameter of the hole will be 0.25, and specifying the thickness of the wheel to be exactly what is specified here. So let's see again what is the thickness of the wheel that we need to use. So the wooden wheel, 3/4, no. Okay, so it is a 3/16 and a 3/4. Okay, 3/16 is the thickness. 3 divided by 16, and 3/4 will be the wheel diameter. And now I will just revolve this feature, revolve base, and here is my wheel, and I will add also some fillet, and here I will add a little bit bigger fillet, maybe, actually 1/8 will be a good size here. 1/8 is too big. Let's say we'll go back to the 1/16 and the 1/16. Okay, and here is our nice wooden wheel. I can also put like maybe a little bit like here. I can put maybe a chamfer of a 1/32. Tiny chamfer to let this wheel to easy go onto the axle, actually just on the one side. And I will save this as a car wheel. Derby car wheel. Now I'm ready to start a new assembly. So File, New, and I'm going to start an assembly. And my base part that I'm going to bring will be what? Will be the car body. So I bring the Derby car body as a fixed part. Now I need to get my dowel pins. And dowel pins I'm not going to make. Dowel pins are the standard parts. So I will pick them up. This time I will use the SolidWorks library. I will not go online. Where is the SolidWorks library? It is this button here, which is called the design library. So let's hover over the design library, left press, and then we go again to the design library and toolbox, and then click edit now. And we want NC inch. And now what we want to put here? Here are the pins. And let's see the dowel pins. So the tapered, grooved, straight. So let's actually move this a bit here. So let's see where we have the dowel pins. This will just be the straight pin. And here are the dowel pin, the standard one. And we will left click on it, drag it until it is here. What is the size of that double pin? Is a 1/4. And what is the length that it is asking us to place the dowel pin? The length of the wooden dowel pin is 1 and 1/8. 1 and 1/8. So if I go here, I can find the length of 1.125. What is this one here? 1 and 1/8. And click OK. And I will also click OK here. And I will put another pin here. So look, I got my 2 pins, which are from the standard parts. Now I want those 2 pins to be equally spaced, to be centered around this body. To do that, right now, by placing the pins, what happened? SolidWorks have its artificial intelligence figured out that this pin is aligned with the hole, because that's where I drop it. So you see, so it's aligned with the hole, but it doesn't know how deep, and there is no way to know how deep I want it. So to make it to be perfectly centered, I will go to the assembly, and I'm going to go to the mate, and there are advanced mates. So if I click advanced, there is a width mate. And how the width mate work is to select the 2 sides of the body, and then select the 2 sides of the pin. And look what happened, they automatically got centered. So essentially, whatever I want to center to, and what I'm centering, just go here. And I will do again this on the other one. So click width, click on this face of the pin, and on this face of the pin, and then width selection. They are interchangeable, it doesn't matter which side we use. And here is our dowel pin. Here are our dowel pin inserted into the body and centered. Now, okay, there it is. Now what I want to do, I want to add the wheels. Insert component. So we bring a new component which we have designed, and that's the Derby car wheel. And we will just put it somewhere here. And now I'm going to mate this wheel. First I'm going to make concentric And then I'm going to make it flush. So I'm going to make the surface of the wheel. Actually, let's see. Did I turn it in the right direction? Nope. So in that case, what I need to do, I need to go here on this concentric mate and edit. Because remember, our wheel is not symmetric, okay? Here it is. So if I click on a mate alignment, I can flip the wheel around. So now it is symmetric. Now, what I want to do is to mate this edge and this edge here. They are already concentric, so there's there to mate. However, what I can do, I can mate the coincidental, this face and this face. And if I do this, look what happened. I have my wheel right there. I can now do, however, I should offset it a little bit. So let's figure this out. How this wheel should sit. It should sit like this, so that there is some space there. So, and to do this, what I will then need to do, I can try to make tangent maybe this edge with this edge. Let's see if that will work. That will not work. I can make them coincident, but that will also, for the edges, that does not always work. Nope, that's not going to work. So in that case, I will need to offset for whatever is this dimension that we put. So that's the 0.03. So I can offset, I can use the offset, mate offset in distance, 0.03, and the offset will be between this face and this face. And there it is, perfect. Okay, now the wheel is in a position. The wheel can rotate together with a, let's see, yep, that's it. So now what we need to do next? We need to put all the rest of the wheels. And can we actually, do we need to do it with a, do we need to do this individually, or can we use the array? Well, we can do another wheel here, or we can array it for the distance between. So let's see what was our distance. If I show all dimensions here, 2.125. So let's do that. Let's do the array and then mirror. Let's go back to our assembly. And let's save this for now as a derby car. Derby car. And what I can do, I can array it for the 2.125. So if I click on a linear component array, direction, I can choose this edge of the car body, instances 2, and the distance 2.125. And I will click for the part, component to pattern, this, and I'm going to click the direction reverse. And let's see what will happen there. And here is my pattern component. So how cool is that? That I was, and now the last one will be to mirror it. And actually, to mirror it, I should do, the easiest way will be to use the cardinal plane, but I can also insert a new reference geometry, or I can go back to the body of to the derby car body. And when I clear, and instead of extruding it a one direction, I can extrude it a mid-plane. So that way, it will be all already centered. So when I go to the assembly, I will not need to create another plane. Yes, update. Okay, now what I can do, I can just use my front plane, which is coincidental with the body front plane, and do the mirror of the last two components. So if I go here on the components, mirror components, and what are the components that I want to mirror? Are the two wheels. Click OK. And we are done with making a derby car. So how about this? So now everybody will make his own, and everybody will have slight different car, with a caveat that all of them will stay within the same dimension range, that we all start with the same piece of the wood. Okay, thank you.